Hello again. This time we are going to focus on the order and linearity of a differential equation. We are still on the chapter Introduction to Differential Equations. So here for each of these five different differential equations, let's try to determine the order for each and the possibility of linearity. Let's start with the order of each of the following differential equations. We can examine the order of our differential equation by looking at the expression, just like this one here, the type or the order of the derivative of a certain dependent variable with respect to its independent variable or variables if there are. So let's start with the first expression. This is obviously of first order. This is of the first order, as you can see, because we have here the derivative of y with respect to x. That means we are just taking the first derivative and no other else. Okay, meaning the first order derivative of y with respect to x is equal to cosine x. So in terms of order, that's the first order. For our second given expression, we're going to separate linearity with and order. Let's just focus on the order first. For our second differential equation, we can see the presence of this notation here. That means it's the second order. Okay, second order derivative of the dependent variable y with respect to its independent variable x. So that's the second order. Let's have this one here. This is an example of a partial differential equation, but still we can still determine its order even if it's ordinary or partial by looking at the expression here. And since it has the same notation here, that means these are still, or this expression or equation rather, is still the second order differential equation, even if the dependent variable v is what they call this one taken its second order derivative with respect to different independent variables. Here it's still a second order. Now how about our fourth example here? Now take note that the first expression or term is raised to cube, but this will not affect the order of a specific differential equation. When you look at this one here, it's still second order. The exponentiation will not work, just like here, thinking that it would become 2 raised to 3, so probably loss of exponent will become it's 6. No, it's still the second order differential equation here. Okay, so it's still the second order derivative of w with respect to x, and of course this is 1. The larger between the two is a 2, so that's the second order. Now, for the fifth rather, we still have here partial differential equation, but we can see obviously this is on the first order differential equation. Okay, now let's talk about linearity. Okay, when you talk about linearity, it should follow this is actually the linearity is concerned first and foremost with the concept of ordinary differential equations, which will tell us in the meantime that the third and the fifth, because they are under partial differential equation, not applicable muna. Okay, not applicable for this case. For the concept of linearity on ordinary differential equation. So let's have not applicable this time. So let's focus, or we can identify the linearity on the ordinary differential equations, first, second, and the third equations in this item. So how do we say if it's linear or not? When you talk about linearity, it should satisfy, for the linearity of ordinary differential equation, it should satisfy this general form. We have a sub n, a constant, times x raised to the nth order derivative of y with respect to x, plus another constant, let me redo it, okay, plus another constant a sub n minus 1 and it should be in decreasing order. So the n minus 1 order of a derivative of your y with respect to your x. So you have n minus 1 there, plus as it goes to a sub 1 times x and the first order plus a sub 0 x and y, okay, depending on what's the value of x, is equal to a certain function, let's say g of x. So I should follow this idea here. Linearity means there is a decreasing pattern on the order of our derivatives. If we're going to look at that, our first one, since it's on the first order, and we don't have other, because the point here is when we say about linearity, with respect to a certain variable, so we could only expect here to see certain variables like x and y, and there should only be two variables here: the specific independent variable and what they call this one, dependent variable. But of course, you could also expect some parameters as long as that parameter is not subjected to any form of derivative. So we only have here x and y, and here, since we have the cosine of x as your g of x and we don't have other variables there, so this is a linear, or that's considered to be a linear differential equation. We talk about linearity. Now, for our second form, okay, this is what I'm talking about. We have here the second order the derivative of y with respect to x. And there exists a process of parameter here. But this parameter is not subjected to this expression here, and hence it could take any value of a constant. Okay? And since we have here the presence of y as indicated by this last term here, this is possible to say that this is actually linear. Okay? That's linear because you only have two variables are still the y and x. Probably x here is equal to 1, something like that, because we cannot see x there. And k here is just a parameter, and it's not subjected to any form of what do you call this one, a derivative with respect to x or with respect to y. So it's still linear. The third one here would probably follow the same concept, and since we have here x, right? We have x and y. You can take y as your parameter for this case, okay? And you will have your w here because that's what your value here, or your variable here. You could let your what you call this one, y as your parameter, and you could consider that. But since we have here the presence of an exponentiation, okay, the exponentiation on the second order derivative of w with respect to x, this makes this expression not linear, because we can see here that for our form for linearity, we do not subject our forms our derivative forms in dy over dx, or the first order derivative of y in terms of x, and its other forms in increasing order of derivatives. We do not subject them to any exponentiation. There could be an additional explanation to this, but just for this time, I could really say that this is not linear for this example. So this is the video for order linearity of these 5 differential equations. Thank you very much for watching.